Welcome. Today, we're diving into why properties matter, the building blocks that shape how things look, feel, and behave. Understanding these fundamentals helps us create with purpose and clarity. Let's explore how paying attention to properties can transform our work in meaningful ways. Let's start with the basics. Matter is anything that has mass and takes up space. That's the simple definition. But to really understand matter, we look at its properties. These are the qualities or characteristics that describe what matter is like. And importantly, matter can be measured, whether it's weight, volume, or other traits. So, properties help us identify and work with matter in a meaningful way. Let's start with something simple. How would you describe a can of soda? What about an orange? Think about their shapes, textures, colors. These physical properties matter. They shape how we understand and interact with objects around us. Now, take a minute to brainstorm, jot down as many details as you can. This quick exercise gets us thinking about the importance of physical traits in everyday things. Let's take a moment to reflect on what caught your eye about the objects we looked at. Was it their luster, how shiny or dull they appeared? Or maybe the texture smooth, rough, or something in between? Shape and size are obvious clues too, as is color. Now, think specifically about the orange and the can of soda. Which of these physical properties did you notice? These details matter a lot, so if you spotted any, raise a hand and share what stood out to you. Let's talk about some key physical properties of matter, the traits we can observe without changing what a material actually is. For example, the boiling point is the temperature, where a liquid turns into a gas. Thermal conductivity tells us how fast heat moves through a substance. Malleability is all about how easily something can be shaped or hammered. And the melting point marks when a solid becomes a liquid. Did you notice any of these in your observations? These terms help us describe what materials are really like. Let's talk about some key physical properties of matter. Luster is all about how well something can shine or reflect light. Solubility measures how easily one substance can dissolve into another. Electrical conductivity tells us how well electricity flows through a material. And density, that's the amount of matter packed into a certain volume. These properties help us understand and describe the materials we encounter every day. Did you notice any of these in your observations? Now let's dive into testing some physical properties of aluminum foil. We're going to use simple materials, a battery, 3 alligator clips, aluminum foil, and a light bulb to see if aluminum conducts electricity. If the bulb lights up, we've got our answer. Along the way, jot down what you notice. Is the foil shiny or does it have luster? Can you crumple it, showing malleability? What happens when you put it in water? Does it dissolve? These observations help us understand the many physical properties matter can have. When we compare our observations with those of other scientists, we start to see a clearer picture. Yes, the material has a metallic shine. That's a key clue. It's also flexible. It can be crumpled and shaped without breaking. But it doesn't dissolve in water, and interestingly, it tends to float because of its shape, even though its density is 2.7 grams per milliliter. Finally, when we use it in a simple circuit with a battery and a light bulb, the bulb lights up, proving aluminum conducts electricity. Let's talk about chemical properties. 2 key ones are reactivity and flammability. Reactivity happens when substances combine and create something new. Flammability is a material's ability to catch fire, and it's not just solids. Gases and liquids can burn too. These properties tell us how materials can change, forming new substances with entirely different identities. Understanding these terms helps us make sense of the changes happening all around us. Chemical properties really do matter, so let's get comfortable with the lingo. Let's talk about how to tell if a chemical change has happened. There are 5 clues that help us figure this out. It all starts with reactants. Those are the substances we have right at the beginning. When a chemical reaction takes place, these reactants break apart and new substances, called products, are formed. Understanding these terms is key. Chemical properties really do matter, so it's important to learn the lingo. To explore chemical properties, we need just a few simple items. Water, a sandwich-sized resealable plastic bag, and some aluminum foil. We'll also use calcium chloride ice melt pellets, a common deicer, along with baking soda and a teaspoon. These everyday materials help us see chemistry in action, making the invisible reactions around us visible and understandable. Let's dive in and discover how these chemicals interact. Here's a simple experiment to explore chemical properties in action. We start by adding 1 teaspoon of baking soda and 2 teaspoons of calcium chloride pellets into a sealable plastic bag. Next, pour in 2 teaspoons of water. That's about 10 milliliters. Seal the bag right away, then gently move it from side to side while holding it at the top. This hands-on step helps us see how these chemicals react together, a great way to bring science to life. Here, we're encouraging students to share as many observations as they can. The key idea is curiosity. The more they notice, the deeper their understanding grows. This slide invites them to explore chemical properties actively, to ask questions, and to connect what they see with what they know. It's about making discovery a habit, not just a one-time event. Let's get them excited to observe and explore every detail. Let's break down what's happening here. We're not sure if the color changed. It's tricky to tell without more testing. But we do see a new substance forming, and it's warm to the touch. There's also a faint chalky or ocean-like smell, which means an odor was produced. Plus, the bag puffed up, showing gas was released. These clues tell us chemical properties really matter, and they're worth exploring further. So how do we know a chemical change actually happened? It's right there in the bag. A chemical reaction took place. This isn't just about mixing stuff together. It's about how the substances themselves behave, their chemical properties. That's what really matters here. When we explore those properties, we unlock a deeper understanding of the world around us. It's not just science, it's discovery in action. One clear sign that a chemical reaction is happening is the production of a new gas. You might recognize this from everyday life, like when baking soda and vinegar mix and start fizzing. That fizz is carbon dioxide gas being formed, something that wasn't there before. It's a simple but powerful clue that the substances are changing on a chemical level. Gas bubbles mean something new is being created, right before our eyes. Let's talk about how odors tell us a chemical reaction has happened. When tiny gas molecules form and travel to your nose, your brain picks up those signals as a specific smell. New scents mean new substances might have been created. Some chemicals have really strong odors, like hydrogen sulfide, which smells exactly like rotten eggs. So, noticing a smell can be a clear sign that a chemical change is underway. Now, let's talk about what happens when new substances are formed. Chemicals break apart and then recombine, creating something entirely different from the originals. This change isn't just in appearance, it's in their very nature and abilities. One clear sign is when two liquids mix, and suddenly a solid appears. We call that solid a precipitate. Understanding these changes helps us recognize chemical reactions in action. Let's talk about temperature changes during chemical reactions. Some reactions absorb heat. These are called endothermic. They break chemical bonds and feel cool or cold to the touch. Others release heat. Those are exothermic reactions. They form or break bonds and feel warm or hot. Temperature shifts like these give us clues that a chemical reaction is happening. It's one of the key signs we look for when learning the language of chemistry. Sometimes, a change in color is a clear sign that a chemical reaction has taken place. Imagine sunlight hitting a photo in a frame. The energy breaks down some of the chemical bonds in the molecules. The result? The colors start to fade. This fading isn't just wear and tear, it's a chemical change happening right before our eyes. Color shifts like this tell us that the substances involved have transformed in a meaningful way. Let's take a moment to review what we've covered. First, we looked at two physical properties, what they are and how to describe them. Then, we explored the two main chemical properties introduced in this presentation. Finally, we asked ourselves, what are the signs that a chemical reaction has taken place? This exit ticket helps us check our understanding before we move on. To wrap up, we've covered key signs that a chemical reaction has taken place, like gas production, odor changes, temperature shifts, new substances forming, and color changes. We also explored two main chemical properties, flammability and reactivity. Finally, we reviewed several physical properties, from boiling point and malleability to density and electrical conductivity. These concepts form the foundation for understanding how substances behave and interact. Great work following along. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.